Hi everyone, here is a specific heat capacity video. We will be looking at the specific heat capacity as well as quantity of thermal energy, which is referring to Q, and we will use the equation in order to find the amount of energy it requires to raise the temperature or release of energy for change in temperature of certain substances. So let's start with what is specific heat capacity. It is referring to the amount of energy it requires for a substance to heat up to a certain degree. With specific heat capacity, we also need to look at the quantity of thermal energy. So what that means is it's actually, when you think about it, it's almost like the total amount of energy for something to absorb or release in order for it to raise by 1 or 2 or how many degrees. The calculation that we use, or the equation that we use, is Q equals M times C times delta T. Q equals to the quantity of thermal energy in joules, so that's the amount of energy it will require or release depending on the state of the substance. And M is the mass of the substance in grams, and C is the specific heat capacity that we talked about. So this is the substance require amount of energy in order for it to have 1 gram of it being raised by 1 degrees. And the delta T part refers to the change in temperature that is required for the overall for the substance to raise or decrease. Here we have an example of a basic calculation of Q, or quantity of thermal energy. So the question asks, if you're given 250 grams of water, think of it as molecules or the mass of it being 250 grams. It started off at 4 degrees and is allowed to warm to 30 degrees. We need to determine the amount of total energy or thermal energy Q that is absorbed in order for it to change from 4 to 30 degrees. The theoretical specific heat capacity of water is 4.19 joules per gram per degrees. So what that means is 4.19 joules of energy is required for 1 gram of water molecules to raise by 1 degrees. So to calculate that, we use our lovely Q equals M times C times delta T equation. The first thing we need to sort out is actually the delta T, or change in temperature. What that means is if we don't know the change in temperature, we can't calculate this. So it is said that it is raised from 4 degrees to 30 degrees. So if you take 30 minus 4, that would give us 26 degrees. And if you plug in the lovely equation, that would be Q equals 250 times 4.19 times 26, which will give me 27,235 joules of energy is required in order for 250 grams of water to raise by 26 degrees. So here in example number 2, we are going to have to switch the equation around a little bit because we're trying to find the change in temperature this time. So we need to actually isolate this. So the question asks, calculate the change in temperature that occurs when 1,500 joules of thermal energy is removed from 10 kilos of iron. The specific heat capacity of iron is 0.449 joules per gram times degrees. So to convert the kilos to grams is also very important because you can't use a equation when the conversion isn't done. So first things first, we're going to look at the 10 kilo of iron and we're going to change it to grams. So 10 kilos times 1,000, each kilo means that there is 1,000 grams. So that would give me 10,000 grams. And then we're going to look at our original equation, which is Q equals M times C times delta T. In order to change that around, we are actually going to take this part of the equation and we're going to divide it by the same thing. So M times C times delta T is now going to be divided by M times C. The reason why I do this is because then that way I can cancel it out. And what you do to the bottom, you on one side, you must use the bottom of the other side, which is where we're going to derive this final equation that we're going to use. So by doing that, we're going to isolate delta T by itself, and then we're going to end up with Q divided by M times degrees. So, and then now we just need to plug it in, which makes it super easy, and all our numbers is already presented. Our joules, or Q, is 1,500, so we're going to put that at the top. And then we are going to plug in our mass, which is 10,000 grams, because it is no longer in kilograms. We convert that to 10,000 grams, sorry. And then we're going to take the specific heat capacity of iron, which is 0.449 joules per gram per degrees, and plug it in there. So that in your calculator runs a little bit like this. So you're going to have 10,000 times 0.449, which is going to give you 4,490, I believe. And then you're going to take that number and with 1,500, you're going to divide that number by 4,490, which will give you this number, which is 0.334 degrees Celsius. So the change in temperature here is actually only 0.334 degrees. Finally, we're going to look at the last the equation that we're going to use probably. The most important thing is being able to switch the equation around, and you guys should practice looking at how to cancel certain elements on each side so that you're used to moving things around to find the thing that you're looking for. So in this case, we're actually looking at the specific heat capacity, which is C. When we have 600 joules of thermal energy that is being added to 20 grams of substance A, the temperature of that substance increased by 33 degrees. Okay, so if that's the case, then what is the specific heat capacity of substance A? We're going to use our original equation again. We have Q equals M times C times delta T. And we're trying to isolate C. So in order to do that, we are going to divide this side by M and delta times delta T. And what you do to one side, you must do to the other side. So you have Q divided by M times delta T on the other side. So after that's cancel itself out because this is multiplication. And if you have division on the bottom, it cancel each other out. You're going to end up with C by itself, and you have Q divided by M times delta T. And lucky for us, all of this is already presented in a way that we can just plug in the numbers, which is awesome. So all we have to do is we're going to plug in our Q, which is 600J, and divide it by 22, which is the gram of the substance, times 33, which is the change in temperature. So you're going to end up with 600 over 666. You're going to plug that into your calculator, and it's going to spit out 0.909, which is equal to, if you round it up, to 0.91 joules per gram per degrees.